morning, ma'am. My name is Stephen J. Senador. I choose multinomial logistic regression. This presentation delves into the intricacies of multinomial logistic regression, exploring the underlying principles, practical application, and advantages over traditional linear regression models. Understanding multinomial logistic regression. Definition: Multinomial logistic regression is a statistical model that predicts the probability of a categorical dependent variable with more than two outcomes. It extends binary logistic regression, handles situations with multiple classes. Key features: These models employ a softmax function to transform linear combinations of independent variables into probabilities for each category. It is widely used in fields like natural language processing, image classification, and customer segmentation. Some example of multinomial application: logistic regression, sentiment analysis, classifying customer reviews or social media posts into categories like positive, negative, and neutral. Image recognition and identifying objects and images such as cars, animals, or landscape. Media diagnosis, predicting the likelihood of a patient having a specific disease based on medical history and test results. Assumptions and limitation. Assumptions: linear relationship between independent variables and the log odds of each category. Independence of observations. No perfect multicollinearity among independent variables. Limitations: sensitivity to outliers. Difficulty in interpreting coefficients for multiple categories. May not be suitable for high complex relationships or large datasets. Real-world scenario: predicting student course selection. In a university setting, you might want to understand the factors that influence students' choose of courses for the upcoming semesters. This scenario can be modeled using multinomial regression, where the dependent variable is the course selected by the student, and the independent variables include various factors that might influence their decision. Dependent variables: course selection, nominal. Categories could include mathematics, science, arts, business, and engineering. These variables represent the different courses that student can choose from. Independent variables: number of hours of student per week, scale. This variable measures the average number of hours students studies each week. It is a continuous variable that can take any non-negative values. Year level, ordinal. This variable indicates the student's current year in the university: freshman, sophomore, junior, senior. It is an ordinal variable because the categories have a meaningful order.